So if we want to pull in our files, as we left off yesterday, you don't necessarily have to start with all of this information, but since it's already there and it's already in a project format, we can go ahead and just load that in. I've made this available under day 4 folder in the first after day 3 folder. You can just grab the project file and bring this in. And what I've done is I've just hit the little plus on some of this data to kind of hide it. It's taking up a lot of room, so just kind of squeeze that information down to one line in a lot of these things. And you can still turn on and off the visibility of these individual items without really needing to have them expanded. So let's walk up here. All right, so to create, what we need to do is to start building the framework for CMS-Wave grids. And so what you would do is to select under map data, you'd right-click and choose a new coverage. And for that coverage, you would go under models and choose the CMS-Wave. And then it would show up over here in the data tree. Once that's there, you can select that coverage. So you just left-click on it just to make sure it's active, and you get the updated tools that are available. And then just as we did for generating a quadtree grid, we'll do the same thing for generating a Cartesian grid, but it's under the CMS-Wave coverage instead of the other. The procedure is pretty much the same. So you would click the button for create a grid frame, and then you would start clicking out the various points to define 3 lines, 3 edges for the grid. The difference between this and the quadtree way of doing it, CMS-Wave grids always start in the offshore. And so you want to make sure that the very first point that you choose is in the offshore. It can be at the top of the domain that you want to add in or the bottom, it doesn't matter. But it has to go from the offshore to the inshore, close to shore and land part. And then you have to specify a third point to define the back edge. Once you do that, you'll get a grid frame. Don't worry about being exactly accurate. We can always modify this like we did before. So you get a grid frame, and what we can do is to resize the grid frame to match the area that we want. And a lot of times we will want the wave grid to be about the same size, if not a little bit larger than our flow grid. And that's just to ensure that we have appropriate wave type information on our lateral edges, and we don't have to worry about extrapolating any information which may introduce a little bit of error. We do handle the cases where the wave grid is smaller than the flow grid, but it's basically taking that last information from the wave grid and then extrapolating it out on the lateral edges with a certain distance so that it covers all of the flow and you don't get any differences of areas that have radiation stress forcing and other cells that do not, which would cause some significant eddies on the site. So you would want to resize this grid to about match what you have on your other already created grid frame tool. One thing to note about the grid frame that is created, the IJ triad, which is this, it's hard to see because it's unearthed with these arrows, but this will always show up on the grid frame that lets you know that this is the corner, the point of origin, and it shows you the I direction and the J direction, and that I direction is shown towards the shoreline. So that's a quick way to kind of look and make sure that your wave grid is going to be set up correctly. If it's going the opposite way or some other direction, then those waves will start at that edge and move in that direction. So it's one thing to keep and make note of. So basically what I had done was essentially the grid frame was created here, and I just turned off the scatter data and then turned back on my quadtree data so that I could see what that quadtree grid looks like. And then once I move the grid frame, it looks about like this. And one thing to note is you don't really need to have the back edge fully contain all of your bearing. A lot of times you'll have a loss of energy, and so by the time you reach a certain point back here, all that wave energy is dissipated. And so you can save some computational time by eliminating a few of these rows on the back side. It might be good to start out with it a little bit fuller and just see through time where that energy dissipates fully, and then you can come back and shrink your grid to that location and then save, But in this case, we're just going to make it a certain size on the back side just to save some computations. So if you double-click the grid that I ended up with, this grid frame, these are the dimensions and the location of the origin and the x and the y, the angle that we're using, and the distance of the actual grid from that origin in the I and j direction. So if you want to come back later and recreate this, we have the numbers already set right here that we're going to be using. So the next step, now that we have the grid frame developed, and you see it's still here in purple outline, is we need to tell CMS-Wave about where the resolution is going to be added. So by default, it would default to square cells, which is perfectly fine. It's just you're doing a lot of computations in areas that you really don't need that much resolution. So if you've got the resolution to appropriate levels, like you would need to go through that inlet, then you'd have 10 to 15 meter cells throughout the entire grid, and it just would take a really long time to compute. And so we want to set specific points that we are going to start our refinements, and then from those points it'll work and increase to some other size that we're going to define later. So the first thing to do is to come in and click the Create Feature Point tool, which is right here, and you would just create 2 points. You can do more than that if you need extra areas of resolution, but for the most part, when you're doing waves, you don't necessarily need a lot of refinement in areas outside this area. So what we typically see are about 2 points to define the resolution for our wave grid, and then it can expand out from there, and I'll kind of show what that looks like. And so we've created these 2 points, then we would want to select those 2 points with the Select Node tool and right-click once they're selected and choose to edit the node attributes. Pulls up this dialog, and so you can do 1 point at a time or both or however many, but whatever is selected will now be assigned these base cell sizes. And so these units are what we have set as in our display projection, so our units are in meters. And so what we're going to do for these 2 points is say that we want resolution both in the I and j direction of 10 meters, and then we would increase that from there. So you can select one or the other or both directions, and there's some times where you might need that or want that, and other times, but I generally just do set both directions at one time. That limits the number of points that I really have to create. And the note here is that refinement does start at the feature point center, and it increases as you extend outwards from that center. Next point, part after you've created those points is you would just want to take your grid frame and those refined points and create a Cartesian grid. So it's relatively simple to do that. You right-click on the coverage where it says CMS-Wave over here. Right-click and choose Convert Map to 2D Grid, and it pops up this dialog box. You can give your grid name a different name if you want. This is all the same information that we previously saw when we generated that Cartesian grid frame. But it's changed a little bit now that we have those refined points. So it's added these sections here for using refined points to define the cell sizes instead of a constant. But note that this is the maximum cell size. So this is the largest cell that's going to be in the grid, not the smallest. So you define in both the I and J direction the cell size. They can be different, but for the most part, I always set them the same. It's up to your preference what you want to do. There's also a maximum bias. So this basically governs how quickly the resolution is increased, or the grid cell sizes is going to increase from your refined point location. So I'm not exactly sure how this goes, but it needs to be above 1. It starts out as a default of 1.1. In some cases, we want to make that transition to larger cells a little bit slower, and so we reduce that. I try to think of it as maybe 5% increase or something like that. But it's not truly that. You just have to play around with these numbers and see what it looks like. And I'll show a couple of examples in just a few minutes about that. The other thing in this section is these boxes for use inner growth. And that basically tells SMS when it's generating your Cartesian grid whether or not to keep the cell sizes between your refined points the same. Otherwise, it would start, of course, increasing that resolution to the default that we've set. And so you would immediately, from those refined points, start seeing it to grow. And I'll show an example of with this turned on and with this turned off. The next section is basically to make sure that you set your scatter set, just as we did previously for the quad-tree grids. So you would choose the scatter set, select here, bring up another dialog, and allow you to choose which scatter set that you have loaded, or give it a constant. So this is the example that I wanted to show about using the inner growth box checked and unchecked. And so by default it's checked. We're going to change that to have it unchecked when you first come in, because that's how we typically do it. Otherwise, we would need to add several different refine points to keep the resolution what we need. So with these choices here, we have only 2 cells across, where we really need 8 to 10, maybe 12 cells to carry the wave information through this inlet. And so throughout this process, you can build several grids with moving these refined points around a little bit to minimize the spacing. You just probably want to make sure that you have enough cells throughout your inlet to a specific distance in the back so that you can carry that information forward as it marches forward. The other option I mentioned earlier was the bias, and so this is an example of changing those values. So the default is 1.1. We still have that option unchecked, so it keeps the resolution consistent and constant throughout between these 2 points. But out from that, you can see that the cell sizes grow a lot faster in this value of bias as opposed to this value of the bias. And so it just gives us a little bit of extra space as that transition starts, keep the model a little bit more stable. So just play around with that number. If you make it too small, you'll pretty much have square cells throughout your entire grid. But it's up to you what values you use for this. Once you have the resolution set, we have the symmetry set, we have the grid created, we need to start specifying a little bit more information about how we're going to be forcing the wave model. And so I went ahead and saved out a new copy of this information and put it into the day 4 after wave create folder. So if you wanted to start from this point, you can have the same files that we're working with in this demonstration. I've done that a couple of times for this talk so that we have enough information to start over. So the next thing that you would do for spectral input, there's different ways of introducing spectral energy for CMS-Wave or any other wave model. And so those are basically, you can do it with simple information like wave criteria. I have got a wave height, period, and direction, and some other spectral defaults that you need to know based on those values. And I can set and create certain size waves that I want to just test out. If I have real information, then I can always go to those gauges, download some files for a specific time period, run an executable that computes and converts that information into something usable by CMS. We're not going to go over that particular thing in this talk, but we will in an advanced talk later this summer. Or you can just use the WaveNet like we described earlier and showed, and just grab those files directly from where it saves them from WaveNet, and then input that, and I'll show you how to do each of these different tasks. So first is the simple spectral input, but before you can do anything, you have to have a place for that spectral energy grid to be attached to. And so what we do is, I just basically here am showing both the wave grid and the flow grid to show how they relate to each other. But what you do is to make sure that you have your spectral coverage created. And so you would right-click on this map data option up here and go into new coverage and choose under the generic section, there's a spectral coverage. So that's where you would create that. First you would create a point here in the offshore. And we generally, if there's only one point, we usually put it around the middle, but it doesn't matter where it's located as long as it's offshore here. And then, so once that point is created in the spectral coverage, then we can right-click on it and choose Node Attributes, and it brings up the spectral energy dialog. So from here, we have different things that we can do depending on which way we're going to be bringing in spectral input. If we're just going to be creating individual wave criteria based on characteristics, then what we would do is go ahead and create a grid. So you would click this Create Grid button. It'll bring up a Spectral Grid Attributes dialog. So you would want to put here the angle that we had set for our wave grid. And if you remember from those parameters, it was 167 degrees. So we put that value in here. We would choose local. It's also the default. If you had a value and you wanted a different type of grid that's basically global, so relative 0 north instead of a normal directed onshore type of grid, you could choose that. With CMS-Wave, normally these are the options that we choose. So once you set these, you click OK, and it brings up creating a spectral energy grid. So this is the default, and we normally accept those defaults. You can change them a little bit if you want, if you're sure you know what you're doing. But basically, we have the frequency distribution. We start with 30, but some people use 35, 40, depending on their particular situation. Some gauges, the values that we get from those gauges have different numbers of frequency. But if we're just creating these and they're going to be built on generic spectral defaults, we can just choose 30 here and we'll be fine. We have minimum and maximum and a delta between the energy rows, and then we also have the angle distribution. And so this is going to be a full plane grid, so we're going to specify 72 angle bins. So anyway, as this comes up, we just want to initially just accept those defaults. Click OK, and we see the grid that's created here. It's nothing to it. It basically shows us the directions and then the frequencies as you go in, but there's no way to attach the information. So what we want to do is go in and tell it to generate a spectra for this grid. So we'll click that Generate Spectral button. That brings up this dialog. And so there's a few different generation methods. Each one of these has certain parameters that it takes. If you just want a simple way that you're going to be introducing and running on CMS-Wave, we normally just use the TMA. But if you have some other information about wind and things like that, you can also make a couple of different choices. I'm not going to go into any of those in this talk today. But using the TMA, you would want to choose depth for the boundary, and we'll do that in just a minute. So basically, you would see what the offshore depth is of the grid that was created and put that value in here. But one of the first things that you can do is to start assigning some spectral parameters. And so you would just go in here and just enter those values. And so this is a time from the beginning, so I'm just using 0, 3 hours, and 6 hours. I'm specifying specific angles here of -20, 0, and 20, a height of 2 meters, period of 8, and the spectral defaults are kind of based on this period, and they're 3.3 and 50. You can change these if you kind of know what you're doing. But one thing to note, as you're working with these different angles here, or these different parameters, if you click on this line, you notice this -20 degree angle. It will actually show you what that appears up here in this dialog box. And so you'll get a red arrow pointing in a certain direction, and that'll kind of make sure that you know that it's going in the right direction. So a lot of times you'll get the angles from some file, and it may be relative to meteorological convention or some other convention. You may not exactly know what that convention is, and this will kind of show you whether that angle is correct or not. This is the water, this is the land, of course, and you would want to make sure that your waves are being directed towards the shoreline and not away. So if those angles were from a different direction or type of convention, you could change this projection box. So I think there's 3 options, and just see what those values should be. So anyway, we're going to continue on. We've entered the 3 parameters here, and we also entered about a 20-meter depth on that offshore edge of the grid, and then we just click Generate. And so you notice here we get the spectral grid, but we also have something populated here for these various times. And so a lot of times you'll have several values here, and you can click through each one of these and see the representative appearance here on the spectral grid, and then you can look at those integration plots that I told you yesterday about, which I'm going to show quickly. So basically, you can look at the frequency and the direction and just see what these wave spectra look like. When we get into the demo, I'll demonstrate that a little bit. So that's pretty much all you would have to do. Once you generate, it's here. You would click Done, and then save your grid, and you're off, and you're ready to go. The other way to do it is obtaining some spectral information from a gauge or a model output or from WaveNet, things like that. So what I'm going to show here is taking the file that's already generated by some of those tools that get it in the right CMS-Wave format and import that energy directly in. You don't have to create a grid because that spectral file already has all of that information in it. So basically, you would just come over here and you tell it to import a spectra that you've already got. So you click the button. It'll ask what type of file it is. There's options here for ST-Wave, this is another core tool, and CMS-Wave. So you want to make sure that it's CMS-Wave. You go to File and find the location of the file that was saved. So we've got this file saved out in a folder for you guys, Wave Spectra, and this is the name of it. So we've just taken this. It looks like it originally came from WaveWatch 3, but WaveNet saved it. It's got a certain bits of information included there in the title. So we can just click Open here, and again it comes in and we just tell that Remain dialog to go ahead and import that file. And so one of the options now is to have more than one spectral file that you can input and assign to your gauges. And so you can add additional ones through this dialog, but we only have this one. We'll click OK. Specify the angle again. It's got to know how the information from the file relates to your grid. You put in 167, click OK, and then here we see. And so we've got the grid created. We see this particular spectral energy grid and a little representation of this first time that we have in the file and what that wave energy looks like. From here, as I said, you can look at each individual one, or you can just click Done and move on and continue. So we're going to click Done and go into the CMS-Wave model control. So for model control, it's not done with the map module at all, so we can move away from this. It's actually done on the CMS-Wave grid, at least for now. This may change in future versions because pretty much everything is moving towards doing as much as you can in the map module and then applying that to the various models just so that it's a little bit easier to recreate things and mix and match different coverages without having to fully recreate them every time. So, but for now, what we would do is we would make sure that the CMS-Wave grid is active, so we would left-click on that, and as soon as you do that, the tools are going to change a little bit, and you'll see CMS-Wave pop up here on the menu. And so the rest of the tools that we're going to be covering are under that CMS-Wave menu, so you would click that and choose Model Control, and this is the box that comes up. And so it's a lot of information. I'm not going to set much information here, but for the most part, when you first come in, there's a few things that you have to do. And the first thing is basically you have to tell CMS-Wave where it's going to be getting the spectral inputs. And so this is the area that you would do that over here. So you're under the Spectra section. The plane type, we have a half plane, we have a full plane, and we have a full plane with some other type of operations that it does. But for now, we're going to just use this half plane. because in our area, we only have wave energy coming from one direction. Sometimes you may be working on an island where you have wave energy coming from various sides, and you can set that up with a full plane. But for now, we're just going to do a half plane, since most of the waves are coming from certain direction and not both. So what you do is make sure that that's half plane, and then come in and choose Spectral Grid, which basically says I've got my grid set up here, here's the origin, so we want to specify this number 1 edge. Since it's half plane, this is all we're going to do is bring in and force from 1 towards the shoreline. And so you see this is the only one that really is open for us right now. So if we choose this box next to side 1, it gives us a chance to tell us what coverage, what spectral coverage is going to be used for that. So we go and we choose the spectral coverage that we have assigned and hit OK, and that comes back here. The next thing is we need to make sure what time frame we're going to be running. This is important if we are going to be doing any kind of connecting this wave run with a flow run. And so if you're going to be doing that type of steering, you know what the time frame is that you're going to be running for your flow. And so you would come in here and you would update this reference time to be the start of that period. And then what you can do is just click this populate from coverage, and it would go and it look at those wave conditions that originally started at 0, 3, 6, 9, and it updates this information. So this is a reference time in hours from a certain date back in time. So anyway, that's the process that you would do for this. You would click OK and come back to the wave model control. So from here, there's a few other things that you would want to modify. By default, you have no bed friction, so you want to make sure that you want to be a little realistic here. And I normally choose just spatially constant. There's a couple of different options. There's a spatially constant Manning-Venn, which is this one. There's another option for spatially constant CF, which is the Darcy-Weisbach friction coefficient. You would enter values for that in the spatially constant. There's also a variable option for each one of these, and these would match with a data set that you have loaded onto your grid. For this, we're just going to choose spatially constant, give it a value of 0.025. There's a few other options here, allow wetting drying, diffraction intensity, number of threads, things like that. A lot of this is not really that important unless you really need it. So we'll leave all the reflection turned off, the muddy bed, other options. But the values that I have looked at are the bed friction wave. It says breathing, but it's a mistype. It's wave breaking formula. There's 4 options here, and you can make a choice of which one you want to use. There's fast mode, whether you want to run with it or not. And as I mentioned the other day, you can turn that on, speed up your computations for a quick look at what the answers are going to be. And then when you get to production, you can turn that back off and get a more accurate answer. If you want other types of information in addition to the wave height, period, direction, output from the wave model, then you can check those boxes and give it a format. If you wanted to see what the radiation stresses look like, you would turn that box on. And I've indicated that here in the model control. This is pretty much it. This is all that you really need to do. You would click OK and then come back in. And so the next thing that we would want to do is just basically save the project, and that makes sure that everything we've done is saved, and we can pull it back in later if we need to. We would choose under CMS-Wave menu to export the CMS-Wave files, and it would output the files that I've shown here in blue. So that's basically a parameter file, is the .sim, a .dep is the depth file, which holds all the depth and the grid information. STEC is the spectral information. STD are the parameters, and structure is a file that contains any information for any structures that you may have set up, which we have not shown how to do here. We'll do that at a later time. So those are the files that are output, and then you can immediately come in under CMS-Wave until it's a launch. And after you launch it, SMS will give you a window that looks something like this, and you'll be able to see the progression of the waves being calculated through time. And so right here we're just showing out of those 135 wave criteria that came in when we imported that energy. We're on the second one of those, and we're in the 187th column of that grid, which contains 226. So it just gives you some information. You can kind of look at this and see where the waves are breaking, and then when it gets past where it breaks, then you'll be able to see as it approaches shore what the values are. And these are the average wave heights. It might actually be the peak wave height, I can't remember. But anyway, it's along the entire edge of a certain value, not for any individual cell. And that's pretty much it.